For today's lesson on compound inequalities, I actually want to start by having you do something for me. So I want you to pause the video and I want you to graph both of these first two inequalities on the same number line. So whether you printed out this sheet or you're working on your Chromebook and you can draw on the screen, or you just have a random sheet of paper, I just want you to go ahead and pause the video and try solving and then graphing each of these on the same number line. All right, so hopefully you paused and you did actually try this. So in solving, remember that solving an inequality is basically the same as solving an equation, but what we do after the fact is really the main difference. So for the one on the left, we'll subtract over the 5, divide by 2. We should get x is less than 6. Over on the right-hand side, there is one difference in solving inequalities that we don't have to worry about with a regular equation, and it happens in this one, and that's the sign flip. When I do this right here, I'm dividing both sides by -3. I have to make sure that I flip my inequality sign, and in this case, I get x is greater than +4. So if we just put a real quick number line on here, I'm just going to put our key points that we really need to see, because we don't always have to start a number line with 0 in the center. If we graph individually for the first one, maybe I'll use different colors. X is less than 6, that would be an open dot. And less than would mean lower or to the left. If I graph x is greater than or equal to 4, it's greater than or equal to, so I want a closed dot, and it would be shading to the right. What we're going to be talking about with compound inequalities, there are two types. There's and the other one is an or. So think about a compound sentence. If I said the dog jumped over the fence and fetched his ball, that's a compound and sentence. But if I said the dog either jumped over the fence or he fetched his ball, that's a compound sentence with the word or in the middle. So same type of idea here, but think about what the difference is. In the first sentence, the dog jumped over the fence and he also fetched his ball. He did two things. He had to do both. Whereas the second one, it was an either or. The same thing's going to take place with these inequalities. So if I said that these two inequalities were an and, what that means is I'd be looking for where the solutions overlap. So maybe off to the side here, I'll write the word overlap. So in this case, if I look at the way that I drew my arrows, if I extend each one of them, notice how the overlap is happening here in the middle. So if this were an and, what I would end up graphing on the number line is the closed dot. Let's not do it in highlighter. I would graph the closed dot at 4 and the open dot at 6, and I would shade in between. Now, if this were instead an or rather, let's get rid of everything we got going on here. We had greater than 4, less than 6. If this were an or, what we would end up taking is either one. So our final shading for this one would be greater than 4 or less than 6. And this is actually a special case or. We'll see an or down in our next example down here, which is going to happen to be more the norm. The one I'm showing you right now is a little bit weird, but actually everything would work for this example if this were an or, because any number that you choose is either less than 6 or greater than or equal to -4, so any number would work. That's what we're getting into with compound. So solving wise, we do the same steps that we do with single inequalities. Graphing wise, we use the same techniques, the open versus closed, the shading to the left or the right, but then we have to do one additional step, and that's putting the pieces onto the graph correctly. So let's take a look at 3 examples, and then you'll have lots of practice today with IXL to really hash this all out. So example 1. we're looking at m minus 2 is less than negative 8, or m over 8 is greater than 1. So this is an or. And when I'm solving an or, what I traditionally like to do is kind of make a wall, because in solving this, I'm going to treat each inequality as if it's by itself. So over on the left, I'm simply going to add 2 to both sides. So we'll get m is less than negative 6. Over on the right, remember with fractions, the easiest thing to do is multiply by the denominator to get rid of it. So I'm going to multiply by 8 on both sides. So we'll get m is greater than 8. And in this case, I'm going to get rid of this divider and put back in that this is an or problem. So m is less than negative 6, or m is greater than 8. So now, again, let's graph them separately and just see what happens. So for m is less than negative 6, we'll go find negative 6 over here on our number line. And I always like to plot my first go at this above the number line so I can see what I'm doing when I put my final answer down on it. Open dot at negative 6, and I want less than negative 6, so less than to the left. Let's graph m is greater than 8. So open dot at 8, greater than means more than or to the right. Now, since this is an or, either one of these would be true. So I can bring down both of them straight onto my number line and just shade as I did above. This is your traditional or. We end up having kind of like the oars of a boat. They point opposite from one another. One goes to the left, the other one goes to the right, and traditionally with an or, there's no overlap. That's not to say that it can't happen to be the other way, as we saw in the first kind of warm-up activity. But a traditional or, the ends go out. Let's take a look at our other type. And you can see in our bottom two examples here that one of them doesn't have a word at all. The other one has the word and. So obviously the bottom one is an and. But what do we do with this one? What exactly does that mean? Well, this one, think about a sandwich. It's like the inequalities are smushing that variable in the center. This is actually, even though it doesn't have a word, it's assumed to be an and. So anytime you do not see the conjunction between the two inequalities, that it's assumed to be an and in this case. So when we're going over to the graph, we're going to be shading that overlap again. Now, how in the world, you might be thinking, do we solve this thing? Well, think about what you would do. If I'm trying to get the variable by itself, in this case, our variable is n, what might the first thing be that you would do to solve if I'm trying to get n alone? If you were thinking subtract by 9, I would say that was a pretty good guess. The difference here is that traditionally we only have two sides. Well, this time we have 3. So we're actually going to subtract 9 from all 3 pieces. So we'll get negative 10 is less than 2n is less than 8. Now, continuing on trying to get n by itself, what do we do next? We divide by 2. And we'll do that in all 3 places as well. So negative 10 divided by 2 will give us negative 5. N by itself now in the middle. And 8 divided by 2 will give us 4. So now we have n by itself. We've got 2 inequalities. And again, this is meant to mean an and. So one thing you can do if you don't like this format is you can rewrite it in 2 separate inequalities with the word in between. And I'm actually going to do that because I think that'll help us graph it. The first one of them, it doesn't really matter which one you write, but this one is pretty straightforward. N is less than 4, right? If I just ignore the negative 5 for a moment, that's what we would get on the right-hand side. But the left-hand side is a little bit weird because now we're not normally comfortable when the variable's on the right. We can write it that way. It's just not as what we would quote unquote call normal. So in this case, what I'm going to end up doing is flipping everything. So I'm going to put n on the left. I'm going to flip the sign so that it matches. because look at the way that the opening is going. It's opening to the end, and I'm going to put -5 over here. So these two things, the sandwich and the actual write out with the word and, are identical. They mean the exact same thing. Now to go to the graph, again, and means overlap. So I'm looking for where the two shadings end up overlapping one another. So at n is, I'm in purple, we'll do that one first. N is greater than -5. We'll go to -5 and put an open dot. And greater than means to the right or larger. And then for n is less than 4, we have an open dot again at 4, but this time less than, we're shading to the left. So notice where the two graphs are going to intersect. It's going to start at -5, go up to +4, and any number in between those two, not the numbers themselves, -5 and 4, but any number in between would be a solution to this inequality. And that's our and. Note here that this one, we called it a sandwich at the beginning. It's like we're sandwiching the solutions between two bounds. That's your traditional and. Not to say that something else can happen, but that's traditionally what an and will do. Let's take a look at one more. And again, this one is just like the last one. It's an and, but they're writing them as separate inequalities. Just like with the or problem, I'm going to divide this into two parts. I'm going to solve each inequality separately. So first, I'll subtract by 8 on both sides for the left-hand side one. So I'll get x is greater than or equal to 1. And then on the right, again, multiply to get rid of the denominator. I'm going to multiply both sides by -7. And hopefully you were thinking that that means we have to do a sign flip because we're multiplying by a negative number. And again, we want to put that word back in between. So now this one is structured the way that I rewrote the last one. So we can go to the graph and just graph these individually. X is greater than or equal to 1. We want to close dot this time on 1. Greater than shades to the right. And then x is less than or equal to 7. Again, a closed dot and shading to the left. So according to the individual graphs, we have our purple and our pink, but now we want the overlap to actually lie on the number line. So closed dots on 1 and 7. And again, the overlap happens in between. Now, just like with the last one, we went from the sandwich form to kind of the separated form. We can do the reverse here, and it might be easier to write that from the graph. What we would do is write our lowest number and our highest number, variable in the middle, and then, believe it or not, the signs end up being identical because we want the numbers less than or equal to 7 for sure, but we want the numbers greater than or equal to 1. And even though this is technically the less than or equal to symbol, when we read it this way, x is greater than or equal to 1 is how we would read that, reading it from right to left. Okay? So here again, these are the traditional ands and ors, or meaning traditionally it goes out, and traditionally meaning it goes in. That's not to say that you might not see something crazy where, you know, maybe you're looking at a number line and you've got both inequalities are shading the same way. That can happen as well. The key to remember is that and is the overlap or the intersection, whereas or, anything goes. As long as it's a solution to one or the other, we can shade it. So like I said earlier, at this point, you've got, I believe, 3 IXLs to practice this concept, and then you've got the review and the quizzes review before the test on Friday. Please reach out if you need any assistance, and good luck.